We have around 400 registrations and participation from around the world. And good morning, good afternoon, and good evening to all participants who have come in. I would like to thank Merck being the advertisement partner for this educational event. And today's webinar is on setting up of an IVF lab, a critical appraisal. And we are really honored to have a distinguished group of panelists and moderators for today's discussion. All of them got decades of experience in directing ART laboratories and helping to set up the units or in managing kind of IVF laboratories. We are going to walk you through each steps of designing, construction, validation, and commissioning of an IVF laboratory. And it is my honor to introduce you the moderators. Dr. Ashok Agarwal. He's also my mentor during my postdoctoral time. He's the head of the andrology laboratory at Cleveland Clinic Foundation, United States, and also the director of American Center for Reproductive Medicine. And he has ranked in Scopus for his research outputs as the #1 author in the world in the field of male infertility, andrology, and human assisted reproduction based on the number of peer-reviewed publications, citations, and high H index. And also, his laboratory is one of the highly productive laboratory, and he has trained over 1,000 scientists, clinicians, graduates, and undergraduate students from the United States and from around the world. With this, I welcome Dr. Agarwal to today's program. We have very dynamic and young embryologist and a clinician with us today to moderate along with Dr. Agarwal. He's the medical director and the scientific director of Simar Fertility Group in Kerala, India. And also, he's also visiting consultant to some other clinics. And he's also the Young Scientist Award Achiever in the SAR during the year 2020. And he also held many positions in the Indian societies, like Indian Society of Assisted Reproduction, and also the Academy of Clinical Embryologists. So with this, I hand over to the moderators to initiate the program.
Good morning, everyone. Welcome to this very dynamic webinar that we have put together. I want to introduce our panelists, but first of all, I want to introduce Dr. Alex Varghese himself, who needs to be introduced as well. Could we have his slide, please? Yes. So Alex, who is the brain behind this program, along with his colleague, Dr. Persu, is a very well-known embryologist and a scientific thought leader in the world. He is one of the most dynamic person because of his number of activities that he's involved in. He is really one who likes to be involved in the cutting edge ideas for disseminating the knowledge in the field of ART. And he has been very productive as a scientist, as a researcher. As a proof of that, I have a number of books that we have done together. This is our book together about 15 years ago, I think 10 years ago, that we wrote with Peter Nagy. And then it was so successful that we had written last year the second edition, because the first edition became so successful that it was become the #1 book in the world. And the publisher asked us that they have, they based on their marketing, they want us to write another book, and it's been almost 10-12 years. So we wrote a second book, which is even larger and bulkier. And then there are a number of other books that Alex has been involved in, and you can see building and managing an IVF lab, gamete assessment, and then there is clinical embryology. So he is a very accomplished person, so he is definitely the right person to be coordinating this very important webinar. So let's go to our panelist, Dr. Sandro Esteves. Sandro is one of a rare person, and in the sense that he works very hard, harder than many of us in his field, and he has distinguished himself as one of the top specialists in male infertility around the world. So this is no simple coincidence. He really has worked very, very hard and being very focused in everything that he does. And we have a great relationship for a very long period of time. You can see all the accolades and achievements that he has obtained during his span of 30 years since he completed his residency and training in Brazil. And he is actually a great educator, a great speaker, beside a very prolific researcher. He has actually just recently published 2 articles with many other colleagues related to COVID-19 and how to start the practice of andrology or how to begin the practice of IVF. So welcome, Sandro, to the program. Next is, I believe, our next panelist is Dr. Jason Swen. Jason is really a very distinguished and very accomplished embryologist. He has many titles, as you can see, but he is from Michigan, and he conducted his PhD in molecular and integrative physiology at the University of Michigan in Gary Smith's lab, where he was trained one of the best researcher in the field, Gary. And then he went in to receive his embryology training with Rusty Poole in Texas. So he's very well trained in the art of ART, and then because of his talents, he has accomplished a lot. He is the corporate director of CCRM fertility chain, and he oversees a very large number of clinics all over the world. But he is also a very popular speaker. So we want to welcome Jason to this program. Thank you, Jason, for coming. Now, I think I will turn the mic to my colleague, Dr. Persu, who is our moderator along with me. So Persu, you can take it over.
Hello, sir, and hello, everyone. And thank you so much for this opportunity. And it's indeed a huge thing for me to be amongst this August panel. And so I'll just, because it's going to be a very long and exhaustive panel discussion that we're going to have in this 1.5 hours. And so I'll directly go ahead with the introduction. I think that one of the next panelists is Dr. Giles Palmer. He's a senior embryologist, X-ray certified embryologist. He's currently working as a business and quality manager at London Women's Clinic, Wales, and also the IVF clinics in Sensway, Cardiff, and Bristol. He's one of the initial people who was instrumental in the first PGD baby in Greece. So that is his part of introduction. And though he's actually involved in a lot of articles which talks about clean room technology, quality management, risk assessment, and for all these reasons, he becomes one of the most key factors, or one of the reasons that he's in this panel is because of his profile. And yes, then we have Dr. Yusuf. Dr. Yusuf is the director at the Faki IVF. He handles one of the biggest IVF clinics in the Middle East, handling almost around 3,500 IVF cycles per year. He is solely in charge of designing all the IVF labs of this particular clinic. He works as a consultant to many of the IVF clinics in the Middle East, invites to many, and his special interest is in time-lapse imaging, PGD, vitrification, and quality management. And then we have our own Dr. Pranay Ghosh. He's from Delhi. He runs his own IVF center called Elixir Fertility Center. He's got a diploma. He's a gynecologist who's, for his passion for embryology, has taken a turn, and he's now very focused embryologist. I think probably he's one of the first few X-ray certified clinical embryologists from India. He's an executive member of ACE and also the recipient of the Champion of ISAR Award, which was given in 2020 National Conference. So with this brief introduction of the panelists, I think we can go ahead with the panel. And with Dr. Ashok's permission, I'll start off with the panel discussion. First of all, the question always, whenever we always think about deciding on whether do we really need more IVF clinics, is the first question that everybody has. But yes, the requirement of IVF is currently increasing. The number of people coming to us for IVF clinics or IVF treatment is increasing. For infertility treatment procedures are increasing. Definitely, we are requiring clinics which are very specific issues. Like we need PGD clinics, we need clinics. We're talking about oocyte vitrification. We are talking about social freezing. We are talking about so many extra agendas or arenas are getting exposed currently in this infertility segment, and because of all these things, we are currently now having an increase or more number of patients walking into the clinics. So start off with this, the first question. When you actually start, first let me put my question to Dr. Yusuf. When we talk about starting a clinic, what is the feasibility study that you actually undergo, or what do you actually do before you start a clinic?
Feasibility study is an important part of any business. Briefly, it gives us the green or the red light for this business. And I know personally some IVF projects that stopped midway because they didn't do feasibility study. They encountered a lot of unprotected, unforeseen expenses and a lot of delay. So the feasibility study in its simplest way is how much we will spend and how much value we will get. And it is composed of 4 sub-studies. One is the marketing study. It tells us how many cycles we will do and how much we will sell our service. Second is the financial study. It will tell us how much money we will get and what will happen to our project if there is delay and if there is a decrease in income. Third is the legal study. Legal study, usually the legal requirements are the longest in any IVF project I did, because it takes a lot of time to get approvals from the official bodies. And our part as IVF scientists is the technical study. Technical study is important because it gives information about the buildings, about the installation, equipment and their depreciation, raw material, staffing, furniture and office equipment, and operation cost.
So a very important aspect. I think Dr. Ashok can start with this question, please.
The next question is really about licensing. And I want to ask Dr. Pranay and Dr. Sandro about this because IVF is regulated as a field and as a practice, and there are many regulations for licensing to get the licensing from the government or the regulatory agencies such as HIFA in the United Kingdom or ANVISA in Brazil and ICMR. So what are the things that the clinic have to do to really get themselves equipped for the licensing? What are the concerns? What are the practices? If you can shed some light, maybe Pranav, you can go first, and then Dr. Sandro can take over from there.
Yeah, so when we talk about licensing, it is basically a process by which your unit or your organization is identified as being compliant with a set of required regulations. And usually the licensing is a legal requirement for governmental regulations in a lot of countries. And since it's a part of the legal requirements and legislations, it varies considerably between countries. Like you mentioned, in the UK, you have the HAPA, the Human Fertilization and Embryology Authority, which typically issues a license after the inspection process to confirm that the organization is operating in accordance with law. In India, we have the Indian Council of Medical Research, which has laid down a series of guidelines, which are in the process of becoming a law, the legislation. But as of now, we are looking to these guidelines when we are designing and setting up our IVF labs. So there are some criteria that have to be met regarding the staffing norms and the infrastructure and equipment norms. And they have explicitly mentioned that with regards to staffing, you need to have a clinician who's a gynecologist, a dedicated clinical embryologist, an embryologist, a counselor, and a program coordinator who's akin to the person responsible in the HAPA who's going to communicate with the regulatory authority with regards to the communications that need to be happening. So when we look to the West, we have the directives like EUTCD or the BCTD, the Brazilian Cell and Tissue Directives, which are directives which are a lot more stringent than what we have here in India. So especially with regards to the air requirements, the air quality requirements, with regards to the particulate count, the microbiological contamination levels or the VOC levels, the EUTCD and the BCTD are a lot more explicit about what they really want in the labs. They mentioned that both the directives mentioned that ISO 5 or a grade A air required for functioning wherever you're handling your tissues or gametes. And the EUTCD differs in saying that a background of grade B may be feasible for achieving the grade A in the working environment. The EUTCD also mentioned lays a lot of specific emphasis on the microbiological monitoring with regards to the various methods and with regards to the colony forming unit levels that they want. But if you talk about the VOC monitoring, the BCTD is a lot more stringent in saying that they, with all the ventilations, they need to have activated carbon filter. And they are, in fact, a lot more stringent with regards to the requirement of the post filter and the pre filter. So these stringencies are not observed in the guidelines that we are having here in the under the ICMR. It just says that the air needs to be filtered. You need to have adequate air changes. So that's the difference between the various licensing directives that we have. So basically, the bottom line is that the expectation of the regulatory authorities should be met. And it is the job of the person responsible or the program director to make sure that whatever you're doing in the lab is in accordance with the provisions of the regulatory statutes, and you're meeting out treatment for the patient, you're following the evidence-based guidelines, you're providing the information.
It's basically that it's going to be very country specific. Every country has got a very specific, diverse kind of licensing protocols. So I think we can just go with what is something one of the most stringent ones. I think Dr. Sandros can actually add in here. What do you think what are you following, or what are you doing at your center?
First of all, thank you very much for having me in this panel. I would like to thank Parsu, my close friends, Dr. Agarwal and Dr. Alex. I'm absolutely delighted to participate in this panel. I think the topic is very important. And concerning the requirements that we have over here in Brazil, they are very rigid. The sector is regulated since 2006. So we have a branch from the Ministry of Health. They have a special office taking control of cells and tissue, reproductive tissue. So we have what we call a directive, similar as the European directive. So basically, this is a very detailed list of things that we need to accomplish, not only including, for instance, infrastructure in which they provide very specific, let's say, requirements for let's say, air quality control. But one thing that is quite interesting is that in this directive, they included the need, which is mandatory, to have a quality management system implemented. So they are not saying that the system has to be ISO 9001 or any other system, but the clinic needs to provide proof during the inspection, which occurs every year, that we actually comply with several QMS, let's say, activities as listed in this slide. I will not go through in detail, but I mean, we need to comply with that. Importantly, when the inspectors come to the clinic, they became more and more, let's say, professional these days. They come 2 or 3 people with a long list of questions, checklists that they go through several details. And these visits usually last for 2-3 days. And they stay in the clinic. They come back the next day, they come back the next day until they complete everything. And then we get certified with a license valid for 1 year. We need a medical director and we need someone taking care of the QMS. I'm just showing you now some of the things related to air quality requirements that we published. We had the pleasure to participate in the book that Dr. Agarwal has mentioned about, and we wrote a chapter about the specific regulations in Brazil. Unlike the European directive, I would like to call your attention that in our directive, it's mandatory to have air quality control related to volatile organic compound. So not only air particle, but in our case, we also need to install, it's mandatory to have within the ventilation system control of VOCs.
Okay, now we move on to a really important topic, and the question is about manpower and training. So these are really important issues which really affect not only the bottom line, but are important in terms of finding the right balance between the work that needs to be done and the quality of work that will be done because of how well the people who are working, the staff, the embryologists are well trained. What is the mechanism for both of them? So in terms of the manpower, we would like to learn, and Jason Swain is really uniquely qualified to answer, running so many clinics of all over the United States, and must be managing a very large number of staff. As to how do you decide what is the formula? Is it something you just have to wing it, or you really have certain considerations, number of cycles or number of hours that are required? I mean, what is it that determines the number of staff that are required, and how do you really put together a training plan for these? Not only that, but also competency assessment once the people are trained on a rotatory basis to make sure that the quality of their training and the work that they are doing is really in a way that will provide the best results. So Jason, all for you.
Yeah, it's a great question. Not a easy question to answer. So most people would say that you need to have a minimal number of bodies. I'm giving obviously a US biased perspective. So we would say a minimum of 2 people in the lab for redundancy and also for things like witnessing. But in reality, you usually need even more than 2. But even in a small lab, we would say a minimum of 2 bodies. But in terms of how many total bodies, that really depends on the workload in the particular laboratory. For example, our labs are kind of segregated into embryology labs and then clinical labs. So our staffing model would change or differ compared to somebody who does andrology, endocrinology, and embryology all in the same work space with the same personnel. So that's an important consideration, as well as the complexity of the work. For example, we're a very biopsy-heavy program. We do a lot of PGTA. It means a lot of cryopreservation or vitrification, a lot of frozen embryo transfers. So that plays into our equation. So it's really hard to find a one-size-fits-all approach. Training in a similar fashion, really our approach has been that it has to be customized. So we absolutely have to have a formal training program with a list of every procedure, the number of procedures that have to be done under observation on their own before they're signed off by the lab supervisor or lab director. And we have checklists for that. That varies from person to person because some people just pick up certain tasks faster than others. Some labs may need to start training somebody on one procedure in a certain order than another laboratory. So we give a little bit of flexibility there, controlled by the local lab supervisor or director. And then really in terms of kind of a rough estimate, there are publications that talk about, roughly how many cycles are needed for embryology staffing. It runs from around 120 up to 200, depending on the publication you're looking at. Most recently, there was a publication in Fertility and Sterility that had an actual equation where you could start plugging in things like equipment number of cycles, the type of cycle, and it starts helping you really try to fine tune that. But really, each location is going to have to best determine that based on the factors listed above.
Thank you very much, Jason. That was very, very nice. Now we move to a very important topic from a aspect of businesses, which is the turnkey, and whether to turnkey the project or not. And this in itself is important for all the ART people to know. And Alex is going to talk, but my question here is what is turnkey in the context of ART? Maybe you can shed some light as the concept of turnkey, and then of course whether this is a good thing or it is not such a good thing. I think you will have to provide some explanation for people who are really not so much connected to the business aspect of ART and simply are more focused on their job as embryologists. Alex.
Yes, thank you. And the turnkey projects are very common, especially in the Southeast Asian countries and also for the chain of clinics. So this becomes easier for the investor when it comes to the setting of unit. So the whole thing will be taken care by this particular company. The only negative aspect is that this particular company might provide the kind of equipments that they are dealing with. The customer won't be having much choice. That is one of the issue that can be seen, but it is one of the easiest thing that everything will be taken care by a particular company, starting from the designing to the construction to procuring the equipment. Even sometimes we can see when they provide the freelance or the consultant embryologist. That is one of the aspect. But there are negative side of this route is that the customer doesn't have much say usually on the type of equipments they want in the system. That is one of the things that we see really sometimes. And occasionally we see that the reported lab scientist or the embryologist doesn't have much say on these things, maybe in the initial time. Especially we have seen this kind of things in the batch IVF centers in India especially. So there is also a positive side and negative side of it, but that has to be balanced by the investor or the person who is starting the program.
Thank you very much, Alex, for your comments. So what we understand is the turnkey is really like a complete like a package deal that you are ordering. You are pretty much getting the full meal and you don't have to do any legwork. Everything is done for you by whoever is the company that is in the business of doing the turnkey. You don't have the choice to select the various type of things that you want. So for those who are very picky customer, probably turnkey may not be suitable. But those who want to take it easy and just go with the advice of those who know the best, perhaps this may be the best route. So I think this is completely a very good option, but something that you need to feel comfortable. And you cannot come back and say, well, listen, no, I don't want this time lapse. I want another company time lapse. But then it may be too late that things are already in place. So there are some adjustments that one needs to make and see what is the best way for them that turnkey will go. Now let's move to the next very interesting and very important question, which is what is the ideal way to procure all the gadgets, all the equipment, which is the hallmark of any IVF lab. I mean, we know that IVF lab is a collection of high-tech equipment, and the embryologists are like the masters of managing all these different tools. So what is it? How does it work? I mean, how do we really go about procuring, getting these? Who has the time to research? Where do we find what instrument? Because it's the jungle out there. There are so many equipment, so many micromanipulator. Somebody who's new to the entire area, how do they make all these? Should they do they have some kind of a place where they can get a very impartial rating of what equipment, what has the best experience or best performance in the IVF field? I don't know. Or does it is basically you have to research and talk to people and find out? So is there an honor system? Is there a way like a consumer report that you can refer to? And these are the very important questions, because otherwise you will buy a Rolls Royce and it may turn out to be a lemon, and you would be spending $500,000 into something, and you will be crying after a few months. So this is a question for Dr. Giles. Please take over.
Well, thank you very much. But I think you said it all, in fact. That's basically it. First of all, thank you very much for being on such a great panel. And it's a thing, setting up a lab, which these questions just never go away. And they're particularly the best part of the job for me. We spoke previously about the turnkey aspect of that. And of course, we have said that your choice is out of the window, if you like. But it's always good to involve the embryologist, especially now as large companies and there's a conglomeration of IVF centers that come off. It's always good to keep the embryologist involved, as I've said there in my slides. But it is the duty, and for me the best part, for every embryologist to know the equipment which is out there on the market. And a great way, obviously, is by peer review, by speaking to your colleagues, having these webinars like we do, even more so now, having these webinars. Look at the papers, okay, but the most important thing is what our colleagues are saying, what works and what doesn't work. Because as you know, techniques come and go. And with those, then there's scientific reports. And those scientific reports will then give you a good indication if, in the case of gadgets, if it's worth having or not. And of course, all that glistens isn't gold, and you really have to do your own appraisal once you have your equipment in the lab. So it's just keep on top of things, look at the market, look at the websites, and look at your own needs. Not every lab needs these technologies. Maybe it's not a cost-effective thing at the time, but we can also dream. So to keep it short and sweet, it's just a matter of educating yourself.
Thank you, guys. I think we're just warming up here with these the initial set part of the discussion, and I think we've been quite clear about how to start off with this IVF center. How do we decide on these factors of whether you should make it? How do you procure equipment? Whether you should do a turnkey? So now, once we have some kind of a decision on what to do with IVF and how do we start with this, I think we'll come to a more very specific questions. I think a lot of people in India still are looking at constructing their own IVF centers. There are a lot of doubts in their mind as to how to start with the construction. What are the kind of materials we're talking about? What are the kind of specifications that we should be doing, and all those specific items. So we are entering the phase of infrastructure here. And I think when you're talking about any infrastructure, I think first question that will come is, if you have the liberty of having a huge building and you decide on whether I should actually have the IVF lab at a specific place of the building, or contrary, in a lot of situations, we just have just one small space and we're kind of forced to use that particular area to make an IVF lab. But then if you have given the choice of choosing a place where you want to do an ideal IVF lab, where will you do it? I think Pranay can take this.
Yeah, thank you for the question. And I think this is one of the most important parts of setting up an IVF unit, because this is the make or break. You can change anything in a lab, but you cannot change, you cannot go back in time and change the location of the lab. So once you've decided that this is where I'm going to be setting up my lab, you need to be actually mindful of the zoning requirements. You need to be mindful of the permits and the permissions that are required by the local council or the government, because these might restrict what can be done on the site later on. So have these in written. And then, like you said, it is a trade-off between what you have and what you want. So you can have a clinic in a busy city center or a countryside. So it is a trade-off between the footfall of the patient accessibility versus the air quality. So to summarize, I think it is important that the clinic location should be accessible to the patient with regards to the proximity to the public transport, parking facility, and especially lift and wheelchair access. And once you've decided that this is the building that I'm going to go ahead with, it is a good idea to locate your lab in the lower parts of the building, because the lower parts are lesser prone to vibration during your micromanipulations, and they facilitate the delivery and transport of liquid nitrogen and bulkier equipments. And they also provide easy access and escape routes during emergencies to the patients and the personnel. But that being said, in India, I wouldn't recommend anybody building a lab in the basement or the ground floor, because it is very prone to dust accumulation and settling of heavier gases. So ideally, we would locate the lab on the first or second floor. And if possible, I would also not want the lab to share the walls with another unit, the activities of which you cannot control, so that you are in control of the vibration levels and the VOC levels of your lab. So once you've decided that this is where I'm going to start my lab, it is always a good idea to bring in your environmental engineers who can do a baseline check for the particulate count with regards to PM2.5, PM5, and PM10, and do a serial testing of the VOCs. And this might give us an idea about how polluted an environment are we looking at, and do we need to actually install additional measures for air purification before we decide to start the IVF embryology suite in that unit.
Yeah, Pranay, I think this is something which I think a lot of people do have a question as to, like, how do we start? Do we measure something? Because it's just something from a personal experience. We've had a center which was very close to it was a normal, good hospital, good, very well done infrastructure. But nearby the hospital, there was a nice bakery, and we could actually smell good, cakes being baked, and it used to be a nice smell. But then I don't know if something to do with the kind of strong smell that comes in. Is there any way that we can, I think if any of the other experts can actually comment on it, but is there any other way that we can actually decide, should we not do it here? Should we decide against doing it? Because the minute we decided and changed the location of the particular lab into a different building in a different space, the results started coming up. So there was some contribution to the environment or that particular area to the IVF environment inside that particular lab. Is there something else somebody can add? Sandro, Giles?
Yeah, I can continue, because I think I'm also contribute to this part. I think it's essential to have a risk management analysis. I mean, there's no, let's say, magic formula that we could, let's say, apply everywhere. We need, obviously, to follow their regulations, because the number of rooms and the way we design our labs are also regulated. We need to follow those things. But I feel it's essential to have a risk management analysis. Obviously, the air quality control needs to be much more, let's say, stringent in a situation where the clinic is located in a polluted city. So we need actually to understand the environment, the number of people working in the lab. So this is important issues to consider when you actually design the infrastructure. So to my point of view, one of the fundamental things that I do when I consult for clinics willing to start a new lab or renovate a lab is planning. We need to dedicate a lot of time in planning. This is very important. And we need to have technical expertise. You can bring a company, but if you are not the expert, they can sell you things that you don't want. And in few years, you will want to resell, and it's almost for free. So you need to acquire and learn the technical expertise to understand. Even these companies coming and selling you air quality control, you need to have a deep understanding. So my advice for clinics willing to start a new lab or renovate a lab, get the technical expertise from one or more people if you don't have it, and then try to plan your infrastructure the way you want to be like 10 years from now. Because a common mistake is that people try to make the lab and the clinic very, let's say, adequate for today. But how about tomorrow? It's going to be very hard actually to renovate. So always try to think ahead, and then have some extra space available for you to, because if you have a good lab, if you have a good clinic, it's likely that you have more and more patients with time, and you need to provide the services in the most optimal way. Obviously, we need separate rooms. I sometimes see people having, let's say, the cryopreservation room and the IVF lab together. This is inadequate because we need positive pressure in one, negative pressure in the other. So how could you combine, let's say, storage place inside the IVF lab? Sometimes we see it. So I think it's very important. I mean, the message here is to have a risk management analysis, apply the quality management system concept, and try to get technical expertise. Not only following the regulations, but also knowing what you are doing and why.
Okay, thank you very much, Sandro. I think he has already covered this point very, very well. And we can move to the next topic.
Yeah, Dr. Ashok, there's one clarification I wanted here. How specific are clinics around the world talking about a separate theater for embryo transfer? Or can the same thing be done in the same, your pickup as well as your embryo transfer can be done in the same theater? Because there are a lot of these regulations occasionally that come up saying that you need to have a separate room for embryo transfer. You don't need it to be that clean as your theater, but you can. So what is your take on it, Sandro?
Well, over here, we can have the embryo transfer room, let's say, use it in common with the operating theater. So we are allowed to have, let's say, the transfers performed in the operating theater as well. So in our clinic, for instance, we design, let's say, schedule the patients accordingly to the number of rooms we have. Obviously, we try to distribute the patient flow. And we have separate rooms for embryo transfers, which are, let's say, we have the air pressure differential from the IVF lab, the operating theater, and the embryo transfers rooms, in which the embryo transfers rooms are not as clean as operating theater and the IVF lab. But in many circumstances, if the workload is not so heavy, we like to have also some transfers performed in the operating room, because they are doing the afternoon. We are doing the oocyte pickups in the morning, so we have, let's say, availability of also distributing the embryo transfers in the operating theater. So over here, according to our regulations, it's allowed to use the operating theater for embryo transfers.
Thank you.
So the next topic or question is really about modular lab concept. The whole idea of modular is not new in terms of many other areas. I mean, we know like a modular hotel room in Japan, where they will put these small little tiny boxes and by the airport or other places or by the hotel where people can relax and sleep, and they can be one on top of each other. So the whole concept in terms of an IVF lab is certainly a very interesting process. Does it really work for a modern IVF lab? Does it decreases the cost of the lab in terms of its upkeep? And is it something that most of the certifying agencies consider to be a good idea, and they will recommend and approve this? And what about the cleaning and keeping? I think that probably is much easier with the modular lab concept. So Dr. Giles is the expert to talk about this and illuminate all of us about this particular aspect of the lab. Dr. Giles.
Thank you very much. Of course, I'm a bit biased because, as you can see in the picture, these are our babies. These are the Shelby modular units which we have. I personally think they're more relevant than ever before. A modular lab, as we speak, can be built or ordered off-site, can be ordered, shipped, and then it can be used standalone, separately, or it could be connected to a system, or even sort of bolted on to your existing building. It's more relevant now with the isolation techniques which we are now facing with COVID-19, but the particular ones you're looking at, 4 people in one day can construct. And the reason where I think they could be more applicable is that when I'm doing the work, and I've traveled the world looking at labs, often there's a lack of expertise locally, or even a lack of material. And again, this is for many questions after this about what materials you use in a lab. Well, this can be taken away in a way that we can now use modern manufacturing techniques to actually order your lab on site and have that shipped there. This could be for not only for developing countries, but even now in countries where real estate, where actual space is very, very expensive to actually have in a lab. These could be units where you could add on very quickly and effectively to produce your clean room, and that's what they are. They are clean room modular units to be a lab or any kind of adjacent room into your lab. So these are highly transportable, and they do offer, as we say, the clean room concepts, which you'll hear again in the following questions about what an IVF unit has to have.
Okay, well, thank you very much, Dr. Giles. So now the next is regarding the IVF lab in terms of the walls, the flooring, the window, the entire enchilada. I mean, how do we really decide what type of wall? Should we have, something like a marble, or should we have just a regular wall? What kind of flooring? It should be Italian marble or something very, very expensive. What kind of windows? So all of the infrastructure that goes into the building, should it be very expensive, very sophisticated, or it should be much more utilitarian and important for variety of functions that will be carried out? So who determines all these things? Where is the book that one can read to say, well, this is the one that you need for your IVF lab? Or is this something like we heard when we were talking about the equipment, that everyone has to kind of finagle on themselves by talking to various people and then trying to figure out what is best? So this is again a jungle out there, and we need to know how to go about walking in that jungle and picking the right berries and for our own lab. So let's hear from first from Jason, and then from Yusuf to answer these questions. Jason.
I'll talk about the IVF lab specifically, not so much waiting rooms and things like that, where aesthetics are probably a little bit more important if you want to have marble walls and things like that. So within the IVF lab and generally within the clinic, you want to be concerned about air quality, as we've heard, specifically VOCs. And so in the US, North American perspective, and not talking about modular labs, which would vary a little bit differently, but in terms of build out, that means usually sheetrock walls because of a weight factor. You do have to consider some building requirements. Stone and things can be heavy. A low latex VOC paint that helps. That building method helps you maintain positive pressure and low VOCs. Flooring is usually medical grade rolled vinyl with welded seams, so you don't have to worry about germs, bacteria, and things getting caught that you might have with tile or grout that may or may not be used, or carpet in other areas of the clinic. And in terms of windows, we try to minimize windows. We don't say we can't have them at all. We actually get more concerned about the impact of temperature and the environmental regulation. A few windows are probably good for embryologists' peace of mind. You can put shades, you can put UV filters. So you certainly don't want to have a corner suite with all windows, but a few I don't think are at the end of the world.
Thank you, Jason. Yusuf, this is your turn now.
Yeah, I will tell you what I did with my labs. For the walls, we used stainless steel panel cladding. If you take a cross section in this, it looks like an ice cream sandwich. Like you have 2 stainless steel boards at the sides, and in the middle there is a styrofoam. And it has a lot of advantages. First, it has 0 VOC and particle emission. Second, it works as an insulating layer. So you don't have heat exchange with the outside, and you can save a lot with the energy and EC bill. And it's soundproofing. You don't hear anything from outside, and it can be ordered as fire resistant also. So in the unfortunate event of a fire outside the lab, it will prevent the fire from coming into the lab, and it can be customized to all labs. And it comes in beautiful colors also. You can choose what color you need for this cladding.
Okay, thank you very much, Dr. Yusuf. That was very helpful. Now I turn on to Dr. Parsuram for the next set of questions.
Yeah, so basically we were just discussing about what is going to be the material of the wall, but very, very specific to Indian scenario. When we're talking about, if Dr. Alex can and Prahoy can add on, what do you think are the materials that are available in India, and what do you think can be used in our labs? Because that's one question which a lot of people in India, when they start a clinic, they always call me up and ask me, like, what do you think should my wall be of? What do you think should be my flooring? So can you just elaborate, very, very, not really elaborate, but very specifically tell me what do you think are the very specific items? I've actually kept it in an order in such a way that probably one is the least used and one can be the maximum used or something like that. So you can actually tell me what do you prefer?
I agree with Jason on these geographical differences in kind of material people can use for the clean room. The basic idea is that you have to make sure that it should be easily cleanable. And second, the material, the wall, floor, or the ceiling should be VOC-free material. So since in a kind of in an Indian scenario, we have mostly concrete buildings, either you can use a VOC-free paints, or you can use the engineered marble, the large marbles with less kind of joints, or even nowadays you get antimicrobial silver nano-ion impregnated bioclads from UK. I think many clinics are using that, or Talclad from Israel. These are kind of sheet, I think, that can be pasted on your existing wall with your people experts, so that can be done. And also for the floor, you can use the same kind of vinyl, sheet vinyl. But everything depends on the kind of availability and the maintenance that can be given by the company that you are asking for the material.
But especially with vinyl, a lot of people talk about a lot of VOCs generated with vinyls, whether the glue that has been used or the kind of...
That is another thing. I think you have to be make sure that the glue that you're using is VOC free, and also you should give enough time for burning time before you start the actual case, maybe 2 to 3 weeks of burning time.
Pranay, you want to add something, or can I go to the next question?
Just that whatever you use, it should be VOC free, it should be easy to clean, and it's not off-gas. That's it. So the things that you have enumerated are the ones that are commonly used.
Okay. See, and now once that you have the room ready, there's always this question is like, now what are all the things that I'll put inside? What do you use? Where do you sit? Where do you have a place to keep your storage? So if Giles can help me with deciding on what are the things that I should be using in my lab, my chairs, my tables, my definitely every lab requires some basic entities that needs to be put in. So if Giles can add in here, please.
Sure. Just to add on that you have to think about whatever you're entering, whether it's yourself or the furniture, to be very sure of the materials and the VOCs which you give off. So that could be the difference between a triumphant start to a very dismal start for an IVF unit, especially a new one. So it's common sense. So don't have any wooden furniture. Things to avoid are the manufactured wood, like the MDF. That or the PVC flooring, as we've said. Try and stick to stainless steel like workbenches, if you like. Now you can go to clean room companies; they've got some fantastic stuff there. Or you can go to like a local supplier that deals with stainless steel manufacture and make some purpose-built sort of like cupboards, if you like, I'd avoid having closed cupboards or a lot of shelves. For workbenches, you can use, as in your walls, material which doesn't give off VOCs and which is non-porous. Chairs, for example, should not be fabric. So again, you should look at ones which can be easily cleaned. And then just, I think, look around, but take your examples from the clean room industry, but you can readily find it elsewhere. You just have to think, is it cleanable, and how are you going to do the infection control afterwards?
Thank you, guys. So another very important question that we always come across is like, how do we kind of, what kind of the electrical connection that are used? What and all should be a UPS space, where and all we can have a generator backup? What are the kind of switches that can be used? It needs to be cleanable. It needs to be, how are the kind of switches that needs to be used? So can, I think Alex and Yusuf add on to these points, please?
Yeah, usually when somebody plan or design the IVF laboratory, we give a lot of emphasis on the type of equipment. So mostly kind of incubators, what you want to get. But along with that, one should give more emphasis on the type of the power system, the electrical integrity, and also you should have a kind of the analysis. What's the power of each equipment? That should be taken into consideration. And all the equipment should be, vital equipment should be connected to an uninterrupted power supply or UPS system. And also you can have a separate generator, especially in India. The power outage is very common, especially in the summer months. And that's a big issue. So I think every major equipment should be connected to either a UPS or when it comes to UPS, there is another issue. I can tell you an incident. There is one clinic I know of my friend. He was doing some FETs for a particular weeks, and the FET outcome was negative. So when they were doing the troubleshooting, they found that the incubator, the box incubator, was connected to UPS, and there was no surge protector. So what happened was that the incubator was showing the 6% or whatever set point of CO2, but when analyzed with the equipment monitor, it was found that it was only 2 or 3%. So that happens when the spike, a power spike happens. It can affect your calibration of the temperature or your the CO2. So that is another area that you have to be kept in mind. And also there are so many other areas that need to be considered when you are planning your electrical connections. Maybe Yusuf can add more points.
Yes. To distinguish, we need to have the UPS sockets in different color. So we will not by mistake overload the UPS. And the UPS capacity should be like almost double of the total equipment capacity. So there will be no overload on the UPS, and it will give longer life. And usually we keep the UPS in a room outside the lab and at low temperature, like 17 or 18 degrees only. This will make the life of the batteries longer. In addition, we do testing for the UPS and the generator on weekly basis, and we document this testing so to avoid any failure in the future. And the other point is we need to have a power failure alarm on the main lines of the UPS and generator, just in case if there is power failure in the evening when there is nobody in the lab and the generator or the UPS do not work. We can get an alarm and take action. And in addition, the last point is the regular maintenance of the UPS and generator, and we should have enough petrol for the generator in the case we have power failure for a long time.
Thank you, sir, because I think especially when you talk about situations like what we have in India, where we have longer power cuts, you should always understand, a lot of people have this question is when you have a generator, whether we need a UPS, but you don't understand that generator has to go off, and only when the current goes, there's always that 1 or 2 seconds, a few seconds for the generator to get on, even if there is an automatic switch on. Alex, you want to add something here?
Yeah, just I want to add one more point. I have seen on sender where the fresh air intake, the ducting was kept near to a generator, the electrical generator, that was kept on the same place in the terrace of the building. So especially we have seen a lot of fragmentation in the embryo, especially on the day 3, that has to be kept in mind. If you are keeping a generator, that should be actually away from the air intake place of your AHU, air handling unit. That has to be kept in mind. Thank you.
Yeah, thank you, Alex. So I think we'll just rush into the next set. I think a very important point, that is air quality in ART lab, and I think nobody more ideal to talk about this, Sandros and Jason. There are a few things, like say, I think when you talk about air quality inside the lab, there's a lot of controversy in what has been recommended, especially by the Cairo consensus. Is that enough, or we need more higher quality? Can you kind of elaborate on what is actually being published and what you're actually following? Sandros can start.
I can start. Well, in my point of view, the ideal air quality should be a lab with as clean as possible. And obviously, there's no magic, let's say, there's no magic solution here, because we have different regulations. The labs are located in different places. The Cairo consensus, for those who do not know it, it was an exercise done by a group of experts. It was a publication came out of it in 2018, I believe, in RBM Online. I have not participated in it, but I have seen that several of our publications were cited in that paper, including several chapters of this book that I wrote with Alex Varghese and also Catherine Warrilow from the US, which is a clean room technology in ART clinics, a practical guide. Well, in my point of view, it's not enough to have an ISO 7 grade air, because when we talk about ISO 7 or ISO 5, etc., it only relates to particulate matter. I mean, we are actually cleaning particles, but not actually, VOCs. And the other important thing is that in the critical areas we are handling the gametes and embryos, we need to have ISO 5. So, if we have a background air of ISO 7, but we are working in a workstation providing ISO 5 air, this is enough. So we need to look at these different situations. But what is very important thing to consider is that we need to combine, let's say, cleaning air, not only particles, but also VOC. And another important thing is how people work in that lab, because the source of contamination is at some extent related to the operators. So if the operators are not properly dressed, they will actually generate contamination. So we need to mitigate contamination by cleaning the air, but also having good laboratory practices, including avoiding generation of contamination. I think this is important.
I'm coming back to you with that particular last point. Before that, I can have Jason add on to something in this particular section. I believe he was a part of this Cairo consensus group.
Yeah, and as everyone knows, when you write a consensus, if you're too strict, you cause issues, because then if a lab isn't up to snuff, so to speak, in this sense, splitting hairs over ISO 5, ISO 7, it can create problems. But 100% agree, VOCs are as important, if not more important, than particle count. And I believe, as I recall, David Mortimer and others who are associated with this, the ISO 7 was still strict. It deals with particle number. But if you're working in isolettes, or if you're working in airflow hoods that are oftentimes ISO 5, you can still have the more stringent particulate working conditions in dedicated workspaces. And walking across a room with a petri dish with a lid on it from a ISO 5 hood to an incubator that often has internal HEPA filtration, internal UV, other decontamination aspects. I think it was a balance between building the entire lab as a, quote unquote, extremely clean room versus having it be a very clean room with, cleaner working spaces within that particular room. So I agree. We need to have strict, very clean air. VOCs are as important, if not more important than particulate number. And I think there's a couple different ways to get that particulate number down in the actual areas where you're handling those gametes and embryos for extended periods.
So especially looking at inside the laminar flows and all, it's very important that you measure the VOCs, not just in the room, but also in spaces like when you do an air quality assessment, you need to do both a regular room as well as in the laminar flows. And this is what I think Dr. Sandoz was referring to. And with this COVID situation that is coming, I think a lot of embryologists around the world are hesitant to work with the full gown and things like that, whereas I think in Sandoz clinic, people are working like that from day one. So this is, I think, you want to add something here, Doctor?
Well, I mean, we have been working with our labs are ISO 5, let's say IVF labs. So the entire room is ISO 5. So people, when I in the beginning, when I was showing this way of working, people say it's impossible to work in a place like that because the embryologist will be very upset, this and that. We need to understand that, I mean, we have skin shedding with a lot of bacteria. This is part of our, let's say, way of shedding and also contamination. I see people putting hands inside the incubator without gloves, things like that. Well, from the microbiological point of view, it doesn't seem to me the best thing we should do. So in our lab, working for more than 18 years in the situation that you see in the upper part of this slide, this is the way our, let's say, embryologists, they have to go like that. I mean, this is like precautionary principle. We don't have a lot of data in the literature concerning air quality control. So most of the papers, the publications that are available, including ours, I mean, these are retrospective analysis or before and after renovation, things like that. We need to cover more in terms of evidence. So I think every single clinic needs to consider risk management analysis and what are the goals they want to achieve. So this is important for consideration, but minimum standards needs to be there for at least everyone to have the minimum air quality control to work with these very sensitive cells, and there's not a lot of protective ways the embryos and the gametes could overcome, let's say, contamination.
Thank you, Sandoz. And another very important aspect is when you're actually kind of designing your AHU system, there's always this question of what is an ideal air cycle change that is required. So if I think Pranay and Giles can actually add in here as to what are we talking about? What are these air cycle changes and what are we insistent on? Because a lot of these centers around India do just have your split ACs. Is that enough, or what do you actually need to do? Or what are we gaining with these air cycle changes? Pranay, you can start.
Thank you. So again, when you talk about air cycle change, it means the replacement of entire volume of the air in a closed box that you're working in with fresh air or recirculated air that has been filtered. And the purpose is to dilute the particles to the resting state. Again, the Cairo consensus has mentioned that you need 15 air changes per hour, of which 20% needs to be fresh air and the rest 80% can be recirculated. But then again, taking on from where Dr. Sandoz left, it depends on what facility you have designed. Is it the air changes for an ISO 5 facility that we're talking about, or ISO 8? So the 15 air changes per hour that the Cairo consensus mentioned is for ISO 7. I know for a fact that Dr. Sandoz estimates his lab, the embryology suite, it's designed to be having ISO 5, and depending on the volume of his lab, I know for a fact that nothing less than 100 air changes per hour would suffice to maintain that. So a general rule of thumb is if you're looking at ISO 7, ISO 8 facility, around 15 to 30 air changes per hour would suffice, but anything more than ISO 5, it would require at least upwards of 100 to 200 air changes per hour.
Guys, would you like to add?
Sure. And if I just add, I mean, if there's one thing that you want to take away is, I think, to read the Cairo consensus. It leads heavily on the work that Estevez has done, who has been leading this field for a long time. And I truly think that the IVF clinics have to move into the biotech arena, if you like, and take on these clean concepts. They are aspirational benchmarks. So obviously the things that you work towards, these things can't happen overnight, but they do show the difference, especially with VOCs, what these new type of labs and how low the VOCs can be to the old established labs. So 15 air changes per hour, as we said, is in there. We know that. It does depend sometimes on if you have an anteroom or an air shower before. This also affects your positive pressure as well. It doesn't have to be so high if you have this physical barrier. It's also an environmental barrier for not letting people come in and out of the lab. And finally, we are the worst contaminants in the lab. We've been using for years in some of the labs I work with clean room clothes. It doesn't have to be the bunny suit that we say, but it can be certainly fiberless material, high neck, long sleeve. It's very comfortable even in subtropical areas, because if you think about the scrubs and you sometimes can tap them, you can see that they give off a lot of dust and a lot of things that you do not want in your air. So I'll leave it for that.
I'll just quickly move into the next question. I think Sandoz did talk about positive pressure rooms, like how kind of when you're designing the rooms, how do you kind of, can you, Alex and Yusuf, kindly elaborate on what was he actually talking about, and what is an ideal pressure that needs to be maintained in these rooms?
Yeah, the Cairo consensus says from plus 30 to 58, but if you go above plus 38, it is going to be difficult. It's going to be difficult to open that room itself. So ideally, I think plus 30 Pascal is okay for the room. And second thing is that even if you put a lot of filters or activated carbon, if you don't maintain proper positive pressure, there is no point to keep, you can't keep it in as a proper clean room. And second, we hear a lot of incidents of anesthetic gases coming from the operating theater to the IVF lab. That has been detected by many people. So this is basically because there is no proper pressure in the IVF lab. There should be a cascading of the pressure from the IVF lab towards the OR and the other areas. So that has to be kept in mind with the proper kind of management of the HU system.
Yusuf, would you like to add something on?
Yes. I think most of the IVF labs are connected to the operation theaters. And once you open the door for ovum pickup or embryo transfer, the differential pressure will go low. Therefore, what I did in my labs, I connected the manometer, the sensor that measures the differential pressure, with the air handling unit. So once the air handling unit senses that there is low pressure in the lab, it will pump more air and compensate the loss in the pressure that resulted from opening the door between the OC and between the OT and the lab. And the purpose of the positive pressure is to prevent the contamination. And on the other hand, we need some rooms of negative pressure also to prevent the contamination. The rooms where we store the dirty and used OT equipment, and the garbage rooms, and the storeroom, the plastic storeroom, because it generates a lot of VOCs. So we need to keep it in a negative pressure. And also the cryo storage room, it should be in a negative pressure in order to avoid leak of nitrogen outside the room if there is leak inside the room.
Thank you, Yusuf. And I think we've got a basic understanding that how important a positive pressure, air cycle changes, and all those things are there. And hence, the requirement of an AHU is so much important, then always when you realize that you need to have an AHU, there's always this question that whether should an IVF lab have a specific AHU, or can we have it as a common AHU to your other theaters? So if Jason and Sandros can add, I think Jason can start.
Yeah, I think ideally to have total control, it'd be nice to have 2 units. For various reasons that may not always be possible. I think you can still obtain the required air quality in terms of particulate count, positive pressure, VOC levels with a single unit if it's constructed very carefully, not mixing air with the proper filtration.
Sandros, you want to add something?
If you can, yeah. I mean, our lab is like that. We have designed it as with a single air handling unit, in which we have about 25% air coming from outside and a 75% recirculated air. But I mean, we have a very, let's say, I consider well-designed system in which we include the VOC filtration with a activated carbon, permanganate, zeolite, and silica. And also we have HEPA filters as the terminal filters. I mean, we have obviously the pre-filters to trap, let's say, the large dust. But having the terminal filters as the HEPA filters, we found it very nice. I completely agree with Dr. Palmer when he said the importance of ante-rooms are good in a way that we have these buffers, actually. We don't have doors between the operating theater and the IVF labs. We have 2 IVF labs working as mirror. So if I have to have maintenance in one lab, the other lab could be still operational. And we have only pass-throughs. I mean, it's important. We have also the manometers installed for us to check what is the pressure differential, things like that. So, I mean, there's several ways, actually, we could design labs and provide the air handling separate, but as Jason has said, if you could design it properly, I think one unit could take control of it.
Thank you.
Can I have a comment on this? In my labs, I made 2 air handling units for the embryology lab, one as working and one as a standby, and the third one for the OT, and the fourth one for andrology, and fifth for the cryo room, and 5 different air handling units, and all controlled by building management system, BMS. The purpose of keeping 2 units for the embryology lab is when we perform the scheduled maintenance, we need to and change the filters. We need to stop the unit for almost 1 day, and so we'll have backup. And in case of any AHU failure, we have a standby unit.
Oh, thank you. Go to the next question. Again, very important. I think Dr. Ashok can take over here.
Yeah, I think if it is okay, Dr. Sandro and others have answered most of this question, so we can, if you are okay, we can skip to the next one.
Yeah, I think we did talk about how important VOC is and how should we measuring it, and I think it will be a very detailed discussion, might end up losing a lot of time. But there's one question I'd like to ask in this particular area about VOCs. We talk about keeping carbon filters in the AHU line, or do you intend to keep a separate VOC, removers inside the room? Because I see a lot of companies coming up with separate. You remember a lot of times we had these large Coda towers which are kept inside the room for VOCs. We had an AHU separately, and then we had this Coda towers. But if you actually have a carbon filter inside your AHU, then do we really need those things, or we can get away with not using the filters? Somebody can add in. Sandros?
Well, I can contribute. I think, well, the units inside the labs, they are useful, but one thing that we need to remember is that all these meshes, which are made of activated carbon, permanganate, etc., they could release some particles. So it's important that after, let's say, the chemical filters, we have, let's say, fine dust filters and then the HEPA filters. Most of the units that are being commercialized, they have, let's say, the flow is like pre-filters, then the chemical filters, and then the HEPA filters, but they do not provide positive pressure. So one way we have to kind of dilute the contamination in the lab is having positive pressure. So when you install a unit inside your lab and still you don't have positive pressure, it's not enough, to my understanding, because obviously you are making the air in better quality, but you are not actually completely avoiding, let's say, bringing contamination in because you don't have positive pressure. Sometimes it's very hard actually to construct labs with, let's say, handling units as we have presented. And then installation of these portable units inside the lab could be useful, provided you actually check what's the quality of air you are taking. Then you need to do some VOC measurements and eventually the particle count as well, to see if you are achieving at least the minimum standards.
Thank you, Sandros. And I think we would have probably understood that how difficult to maintain these kind of labs are. So another very important question here is whether how effectively we, in lower resource settings like regular clinics, smaller clinics, and in countries like developing countries like India, how can we actually get this clean room? Is there any other way that we can do it? Alex, can you contribute something?
In my opinion, there is no shortcut, because basically you are dealing with the pre-implantation embryos, which doesn't have any detoxification systems like our human beings or adult mammalian systems. So one has to make sure that even if it is there is a cost is involved, one has to put a real HU. In India itself, nowadays you get a good HU systems in an economical way, and that is very essential. And you have to appoint a good company, especially those companies who are making HU. They make it for the pharmaceutical industry. But you have to make sure that in IVF, you are more concerned with the VOC. So you have to educate the engineers who are making the system to put the right kind of a VOC filtering systems in your place or in your ducting system. That's very important.
Thank you very much, Alex. So now we move on to some additional questions regarding the humidity. What are the things that can we do to maintain the humidity in the right range? How do we measure it? And how important it is that we do it, and what will be the consequences if this is not done properly in an IVF lab? So we ask Dr. Yusuf, who has one of the biggest IVF clinic in Dubai, to talk about this concept in his own setting.
Humidity is an important factor in the air quality, and it should be comfortable. Like relative humidity of 40 to 60% is considered comfortable.
Can we move the slide, please?
Yeah, here in the Middle East, in Abu Dhabi, where I work, we have a humidity reach 100% in the summer at night. So our air handling unit are equipped with the humidification and dehumidification units that control the humidity. It's connected to the hygrometer inside the lab, and when it senses the humidity is high, it dehumidifies the air in the lab and dehumidifies the air that comes to the lab through the air handling unit. The humidity have some negative effects on the lab, higher humidity, because it enhances the growth of fungus and bacteria, and it can accelerate the rusting process in metal parts of equipment. And when it makes air condensation in the electrical part, it can damage the electric boards of equipment and make the floor slippery and not slippery and increase the risk of falling and make the environment unhealthy for working. On the other hand, decrease the humidity can cause some electric static in equipment and in anything you touch in the lab.
Thank you, Yusuf. Let's move on to the next set of questions. Can we move? So here we have the concept of ultraviolet light and where it needs to be placed and what are the concerns. So ultraviolet light obviously is to really remove many types of infection pathogen from the ART area in the lab, and where it is the best place to install it, and does it have any kind of unintended consequences. So we'll ask Jason and then maybe Alex to comment afterwards. So Jason, please go ahead.
Yeah, so in our labs, we have UV lights in 3 areas. One is in our air handling unit as part of our air filtration system. It was a commercial in ductwork unit. And so staff and I were exposed to those UV bulbs as part of the photocatalytic oxidation process, in addition to other carbon and permanganate and HEPA filters that we have in line. We also have them in our airflow hoods, specifically those that we use for processing cells for genetic analysis to make sure that we can denature any DNA or decontaminate that hood at the end of the day prior to making dishes the next day. And that is enclosed in plexiglass with a shield to protect staff. So although visually you can see that bluish light, that plexiglass shield is preventing the UVC and the harmful UV rays from actually impacting staff. And the third location are in some of our incubators. They're built internally for internal bacterial control. So again, lab are never exposed to the UV light in that third location.
Okay, great. Thank you, Jason. Alex, do you have anything to add to what Jason just spoke?
Yeah, I would like to add just 2 points. I agree with the Jason. It has to be a kind of enclosed, not the open system, because the important thing, you want us to use the UVC light. That is a wavelength or radiation wavelength of about 253.7. And people has a doubt that this UVC light generate ozone, but generally it doesn't generate the ozone, especially when it is in the photocatalytic oxidation devices, either intact, or if you can have for small centers, you can have a standalone system inside the lab that can take care of your air decontamination and all the infections.
Okay, thank you very much. Next question that we have is related to the temperature. And we want to know what is the right temperature for an IVF lab, which is good for the working environment, but also good for the embryos. What will be considered as a good compromise before the staff start complaining? And what about the temperature on the surfaces? So I'll ask Jason again to comment on these important points.
Yeah, I think the room temperature is a tough one because you've got to consider embryology, satisfaction, and as we know, certain people like a warmer or cooler temperature than others. So what we do is we just set a small range, and we make sure that the lab is kept in that range. And for our labs, it's usually in the range of somewhere between 21 and 23 degrees. That absolutely may vary based on a particular lab or a particular location around the world. We certainly don't subscribe to the idea of the warm embryology rooms where you try to keep things as close to 37 as possible. That may be good for embryos, but that's probably not good for equipment or staff. Equipment can overheat. And so really, if our labs, if we have any sort of really hot day or some interruption in our air handling units, when the temperature starts getting above 24, 25 degrees, you really start hearing our embryologists complain, some more than others. In terms of temperature for embryos on surfaces, usually a tight range. From a regulatory perspective, you want to have a range so that you're not too tight, but practically a tighter range is better. So we generally say somewhere between 35 and 37.5 degrees. In practice, we're really closer to 36 to 37 degrees. The caveat being your surface temperatures may have to be slightly higher than, say, 37 degrees that you'd have for your incubators because of your dish configurations and contact points. You may need a slightly higher surface temperature to get 37 degrees or thereabouts in the dish. It's important to measure. And importantly, when you measure, you need to make sure you're using an accurate thermometer, which means that it's been calibrated or up to date.
And these, I guess, Jason, thank you, must be part of the QC, quality control, that has to be done every single day by the staff.
Absolutely. We have written protocols outlining all that for staff.
Yeah. Okay, let's move on to a few more topics that we want to cover. One is the gas lines. Where should the gas lines be, or the gas room be built? Where should all the cylinders be stored? And what is the regulation for this? And how often this changeover of regulator is needed? So there are a lot of questions related to the installation as well as the location and the piping that is there. How do we, what kind of material is the most safest so that there are no pathogens growing inside these gas lines? And that is certainly a consideration even more now with the COVID-19. So I will ask first Alex to make a comment quickly and then have Giles elaborate on that further. So Alex.
So there is a lot of debates and variations on the type of gas lines that is established to bring in the essential gases like nitrogen, CO2, or the mixed gases to the IVF laboratory. Usually it is copper lines, medical grade copper lines in some country as a regulatory thing. But always there is a option like you can use a stainless steel. Many people are using that. Another option is that you can use a kind of PTFE. It's a polytetrafluoroethylene based thing. So that is some of the thing that is suggested that doesn't have a plasticizer and doesn't absorb the gases. And if you use a silicone, there's a chance that if you have a mixed gas mixer, some CO2 can absorb into the silicone. So that actual value that you are getting inside the mink incubator or any incubators that you are using with a pre-mixed gas will be a lower level. So, and also the gas cylinder should be kept on the outside separate room. Many places we can see maybe the gas cylinder is keeping inside the IVF. That should not be the way. Maybe Giles can add on more points.
Okay, thank you very much, Alex. Let us have Giles comment on this.
Sure. I mean, I agree 100%. Not much more to add, but have a separate room for your gas bottles. Have an automatic changeover, of course. I would prefer medical grade stainless steel, shortest possible route, and make sure that the input to the lab is where you want it so that you could position your incubators very carefully. Have 2 manometers, one for pressure, one to turn off when you're cleaning in there. All the ducts should be hidden, okay? They should be behind the walls or in some kind of corridor. And use silicone at a minimum, I'd say, or other inert tubing, a bit like Tygon, if you like, for emergency purposes. And finally, insulate those tubes so they don't have condensation.
Thank you.
So one thing I just wanted to ask was basically because unlike in abroad where we don't have these, when it's a separate room, the lines when it comes to the embryology lab, it has to come through walls. And what we have in India are not hollow walls, like where we can actually pass these tubes. So in that kind of scenario, we might not be able to use these silicone tubes through or any of these flexible. So at that point of time, you do suggest some other way of passing these tubes, like I think Alex, how do you generally do it in clinics in India? When, because obviously copper, again, there's a big debate. So whether you pass a tube through inside the copper tube and then bring it into our main lab, or how do you do it?
Well, also, you can have like...
Giles, you go ahead.
Okay, well, I was going to say, if it cannot be within the wall, then it's you want to avoid corners, but you can have very easy like channels where you can put all your gas tubing in there, whatever size it is, and that's another form of future proofing. All your wires in there as well. a central sort of grid, if you like, around your lab, which you know that's where you're going to have all your inlets, which you can easily access for any other use. But I would recommend you avoid bare pipes, obviously, and the quickest route in should be the best.
Okay. Alex, anything, or we move to the next point, please? Okay. The next question is about commissioning a new lab. Now we have done all the lab work. We got the lab built. The vendor or the contractor have put together a brand new lab. We got all the best equipment. You got your Lamborghini and all these things, and you have a wonderful staff. Now, how long are you going to wait and before you start taking care of the patient? So there is a concept of burn-in. I mean, I hope it's not burning in the entire lab, but what is the concept of burn-in and how long it should be, whether it is a 1 day, 2 day, 1 week, 2 week, a month, 2 months, or 1 year, and how do you really know that you're ready to begin the cases? What is the litmus test? So this is a question for Jason, who has a great experience, and then with our friend Giles to basically cover any other points. So Jason.
Yeah, I'll talk about in terms of constructing a lab. Dr. Palmer will be much more of an expert on modular labs, and his timelines may vary differently. But for us, burn-in is kind of running things for a while to get the air quality and the lab specs up to where we want them. In terms of an incubator, it usually means raising the temperature to the highest point and running it for usually several weeks to help burn off any VOCs, and that's after a thorough washing and rinsing with a non-toxic cleaner and with peroxide and clean water. But it also refers to burning in of other lab equipment to allow it to off-gas, even though we've built these things with as low VOC levels as possible and try to keep them clean. But also burning in the HVAC during construction, even though we ask for certain things to be done in terms of cleaning ductwork, assuming the air handling unit has been put in a clean fashion. We know that has been referred to, local contractors aren't always up to snuff, despite our best efforts during oversight. So that usually for us means running it for a few weeks and then measuring to make sure that the particle count, the VOC count in the lab is where we want it to be. And then we usually do some sort of biological assay, a 1-cell MEA, to make sure we're able to grow embryos in each of our incubators before we ever start treating patients.
Okay, great, Jason. And let's see if Giles can make his comment.
Sure. Well, not just for modular, but any other lab which I sort of look after. You have to get rid of those VOCs and that like new smell, if you like, which you have in the lab. I did a study in 2010, which is still a very popular blog. It's on VitroLife, the website there. It's about cleaning air. And I looked at every stage of a renovation period, and I looked at which VOCs were released. And taking these precautions, which I'm going to say, we could get it down to 2 weeks after the finish of a project, that we could in fact start up our IVF unit. So we looked at the VOCs in the air. Obviously, you have to flush out those VOCs. So you want a higher temperature than normal in a lab. You want overpressure. You want the lights being kept on continuously. And a little trick whichever I can do, which also works well if you have large equipment as well, is to have almost like a false wall or a larger than normal door, which you can let that lab be aerated for 2 weeks. New equipment is then burnt off in another area as well, because you don't want, again, VOCs to be entered into the lab, and then enter again through this false wall and then seal that up. But it does take about 2 or 3 weeks to clear, and we can see that with the toxins in the air. And then, of course, you do all your bioassays to make sure, which, of course, Jason has mentioned as well.
So I heard from both Jason and Giles. So kind of 2 weeks is probably the time for things to kind of all get tested and things are working. In any of your experiences working in this field for a long time with so many labs, did you have a situation where something really didn't go right and you had to delay for a long period of time, for several weeks or a month or two, before you can begin the operation and taking care of the patient and start doing the cycles? Is that something that any of you experienced, and how did you handle it?
If I could add on for that, yes. These are in the ideal situations, and with all the measures which we've said today, and the books you'll read, and the consensus, 2 weeks under the ideal conditions should be okay. But we don't live in a perfect world. We all have the pressures of a business, of course, to open up. The only one thing which I would recall was that you have to be on site all the time. And at one particular project, I turned my back. After knowing all the workmen knew about low vox, they were highly educated. And when I came back, I had some of the hospital staff who were putting on their regulatory signs on the wall, and they were using like benzene-based glue. So we had to stop there, and that was delayed for another 10 days while we completely cleared that away. So again, the trick is, I think, to always be present and always make sure that people know the ideal situations.
Yeah. Well, thank you very much. We'll continue, pursue. I will still continue, and let's try to. I'll tell you when you can take over. Lab maintenance and monitoring. Let's have. The lab is ready now, and everything is all brand new, shining, and things. How and what we have to do in terms of what is the protocol for monitoring, and what are the things that you need to really monitor that can impact on the embryo. What is really considered as the most essential things that need to be monitored, and I believe that there are proper guidelines for that. So maybe Pranav, you can talk about it in 2 minutes.
Thank you. So if we read the CARO consensus guideline on the IVF culture conditions, it says that there is only one thing that is truly important in the IVF lab, and that is everything. So you actually need to monitor everything. For clarity purposes, I would, for a better recall, I break up the monitoring variables into environment, equipment, culture system, and the personnel. So we have talked a lot about the environment. We need to measure all the variables of the HVAC system. So air quality monitoring with regards to the enumeration of the particles, the microbiological contamination levels, and the VOC levels. They need to be done in routinely. So the frequency of monitoring can be defined, and the particle counting can be a part of the BMS or the EMS. What is really important is doing VOC levels, because it can detect a non-compliance or a breach of cleaning and disinfection protocols. And it can also dictate the maintenance schedule for servicing and replacing your filters, especially after a burn-off. So I think particle counting should be including all the 3 variables. Then we have talked about the temperature. We know the optimal temperature range, and we should stick to a small window, because if we have a too large temperature range, our incubators may dysfunction. And we know for a fact that the incubators dysfunction above 30 degrees, at least here in India. Then we know we have to monitor the humidity, because too high a humidity or too less a humidity would cause microbial contamination and static respectively. So when we talk about equipment monitoring, we have the real-time monitoring, which can be done by the use of modern web-based systems, and we can have data that can be accessed remotely from the internet, and alarm systems that can warn us with regards to the equipment dysfunctioning or malfunctioning or breaking down. So inside the embryology lab, you need to do a certain variety of checks on a daily, weekly, and regular basis.
Let's go to the next set of questions, which is the frequency. Now we know we have to do the monitoring. So how frequent this monitoring has to be done, and what are the guidelines for this? So I believe there are a lot of changes and things that have happened because of some of the recent problems, especially related to cryopreservation of embryos. So I want to hear what are some of the new things that you can illuminate, Giles, and then Sandro can comment. So Giles, please go ahead and yeah.
Yeah, okay, I'll try to be quick. Okay, here in the UK, the HFEA stipulate that any essential piece of equipment have to be monitored 24/7. This can be done remotely, but they can also be streamed into nowadays your phone or any kind of quality control app. I've done a recent study. There's a vast majority over worldwide regularities of monitoring. It's usually once a day, but in light of the let's say crisis that happened in 2018 when tanks failures, it was shown that if tank failure starts to happen, that can happen within 12 hours. So you really need to monitor the dewars once in the morning and once in the evening. Telephone lines should also be analog because you can also have problems with your mobile phone details. And I'll leave the rest to Sandra now.
Right. Okay, thank you.
Andro.
Well, basically, in terms of air quality control, we have also regulations over here that we need to do the monitoring. I mean, in terms of particles, twice a year. So we have a company coming in. If you can show me the next slide, I want to show you. Okay. For instance, in terms of the air volume, flow rate, the air exchange rate, etc., pressure differential, we have the manometers installed, so we can check, let's say, every time, 24 hours a day. But for HEPA filter integrity, particle counts, well, we have these companies coming twice a year, and they come, they do the auditing, they do the measurement, and then they provide a report. Concerning the VOC, we use a portable device in parts per billion. So this device is on when we are doing our work. So it's kind of, we are not only taking measurements, let's say in the morning, in the evening, no. It's continuously on. And then if we identify that our threshold for parts per billion is 100. So it is above that point, and then we don't do critical activities. So if we have to open an incubator, we won't do that. We need to remember that part of the air is coming from outside and part is recirculated. So a VOC can build up and sometimes it will build up for short periods of time, and we need to identify when it happens. So the portable devices are very helpful for that. In addition to that, we have microbiological control that we do every quarter according to also regulations that we have here. And we need to do the settle plates and the contact plates using specifically, let's say, a sort of a growth environment for these bacteria and fungi to grow.
Okay, thank you very much. Let's move to the next topic of question.
One thing I would like to add here is I think a lot of people don't talk about the cryo room and the use of oxygen sensors and all those things, because
maybe Sandro can comment on that.
Yeah, absolutely. This is a must. We need to have an oxygen monitor inside the cryo room. And over here, it's also mandatory that we have negative pressure. So what we have here is that every time embryologist, technician gets into the room, automatically when they open the door, the system will try to operate. You don't have to have the system 24 hours a day because, I mean, it's waste of energy. But as soon as someone opened the door, if the system is started to have this negative pressure, that will be very quick. And the oxygen monitor is important to be not very high, not very low, but in the level that someone could faint if the oxygen goes down. Sometimes I see the monitor placed in not the adequate position. So it could be like in a position that the embryologist is working. Because this is when the oxygen level will go down, then the people actually could faint and then have a problem.
Yes, it's no good at being low. It has to be sort of at the height of a person. So of course, if there is low oxygen, then obviously we know about that. So that's very important. And there is calculations very quickly that you can find out the number of canisters which you should have for a certain type of room as well. There's that you can find on the internet about how many storage canisters you should have in a certain room.
Okay, let's move to the next question. So the question here is, what are the steps that one needs to remember, while you are renovating now, I mean, we just built the brand new lab, so I hope it's not a lemon, otherwise you may not have to renovate for a long time. Or if you have a change in the need, or you grew up very fast, that after 6 months or a year or two, you double the capacity and you need to really do something to renovate. So renovate generally means that the facility is old and it requires to be remodeled according to the latest standards, latest regulations. And then how do we really do that when there is work going on around you? So let us hear from Giles. What is it that you will do, and what kinds of problems that may actually introduce in the work that is already going on should the lab be completely shut down?
I mean, a lot of the stuff has been said before, so again, I will be very brief because when you're renovating, it should be as the same as the materials which I've said about starting up a lab. But the question does say, of course, if something else is happening near the lab. Well, education is the key. In my hospital where I was previously, everyone knew they couldn't open a paint pot without first telling the IVF unit, and they take their measures. So education in the facility that you're at is, of course, key. I would say a thing which is very relevant now with climate change and what we've seen over the past few years is there will be some renovation going on in the place you work, next door perhaps, and whatever. That also they have in your system what I'd call like a submarine mode. So you can, in fact, stop the airflow for a limited period of time so that your lab is sealed. And then, of course, has proved wonders for areas where there's been forest fires and other natural disasters.
Okay, so let's have Dr. Persu with this question.
I think this is something which is like very common in our part of the world, that we do a lot of batch IVF. So I'd like Alex and Pranay to elaborate on what they would like to do, especially how prepared, what do they prepare themselves when they're going to start a batch of IVF.
This is a lot of elaborate list of things so that you have to be very careful, and especially since many of the batch IVF programs, it is freelance or the visiting embryologist coming. So if it is a new facility, I think better to have your embryologist come in a few days beforehand so that he can check the systems, whether it is working properly and whether you have enough disposable and enough things in place, and whether the equipments are working properly. And also you should have your engineers in place who has installed things so that they can do the proper calibration before you put the patient, because in a batches you put a lot of patients together, so you have to be very careful. And second most important, I think foremost important thing that I've seen in many of the batch centers in India is the type of because there is no medical gradation for the gases in India. So most of the problems that you find in the pre-implantation embryo quality and the early miscarriages can be due to the gases that you are using. So you have to be very careful about what kind of gases you are getting for your incubators. I think these are the important things that you have to keep in mind.
Thank you, Alex. And I think Pranay would like to add something, or can we go ahead?
Yeah, you say that you need to be mindful that things can fail during a batch, so you should be keeping some items in duplicate, like your oocyte aspiration pumps, the bulbs, spares for your stereozoom microscope and inverted microscope. And once you receive the media for that particular batch, it is ideal to be performing the pH testing for that particular lot of media, as you do with all your medias, and do a sperm survival test. And you need to have a good cryo inventory management for the batch as well, just like you do for your regular batch IVFs. And it is a good idea to have adequate liquid nitrogen and freezing media in case something comes off in your batch, your incubator or your micromanipulator, and you're not able to proceed beyond your collections. So it's a good idea that you have ample freezing media, sperm freezing media, and vitrification media, and liquid nitrogen for your batch.
Okay, I think I'm going a little faster at this point of time. So coming to the next point is, I think we have a lot of these experts here who manage multiple centers. So if like I think Jason or Giles can help me here as to when you're running multiple centers, what do you basically use as a threshold, or you kind of benchmark as to how do we start monitoring these different centers, and how do we make sure that the quality is maintained in all of these centers?
Yeah, there's now the Vienna Consensus, I think, is a publication that a lot of people refer to. We just have key KPIs that we look at, really as it's kind of red flags to determine how we're functioning. Things like oocyte maturity, fertilization rate, blast conversion, obviously more clinical endpoints like pregnancy and implantation. And what we do is we look at those on a regular basis. For us, formally every month, that gives us enough data points to have it be meaningful. Our clinics are medium to large sizes. If you're very large, you can do it more regularly. If you're smaller, you might have to do it less regularly to get enough numbers for it to be meaningful. But we then compare each center to each other on a monthly basis. And then we also compare against a threshold. So we can see, is every lab making the threshold? How are the labs comparing against each other? And if somebody's a really, really high performer, we can then look at what they're doing. Maybe there's some little local factor that's beneficial, and then try to adopt that strategy for the other locations. And so I think, there's some standard KPIs. There's some now recommended thresholds in the literature. But what we do is at the end of every year, we try to create a new threshold. And every year we try to raise our bar higher and higher. So for an example, ICSI minimum threshold 70%, but over the last couple of years, our minimum threshold is now more like 76%. We try to continue that improvement.
Sure.
Guys, something?
Yeah. And to follow on, whether you have many centers or one, obviously the same rules applies, that you have to look after your KPIs. And as Jason said, the obvious ones are in the consensus, but there's FERT rate and also blastocyst utilization. So how many good blastocysts do you get either transferred or in fact frozen? But if it's remote, it's critical that you look at all your pieces of equipment, and I think it says about the environment here as well. And you can only do that if you store things electronically. So that could be done, centrally or by an app, and then you can compare and see which things are actually fluctuating. If you're remote, then you have to look and see if your lab locks are being done. Okay, and that can be checked electronically as well. You can look at your integrity test. You can look at the manometer readings sometimes over your filters to see if you're not physically there, how they're doing. And of course, importantly is your fridges, which have the culture medium in there, and the cryo storage. And there's various ways. There's a big focus going on with cryo storage now, not just with remote monitoring, but also visual aids. So you can see with like a thermo sensitive camera, if those dewars are failing, and it's time, beforehand that you have to intervene. So again, technology is on our side to remotely look at these labs. It depends on their going back on that data and reflecting on it there.
Thank you, guys. And going to the next question, a quick one. I just need one of the panelists to answer this for me. You kind of suspect, it's kind of a difficult question. That's why I kind of put this in. Some kind of microbial contamination that you're expecting, and you just feel that the source is in your ducting from the AHU. So what do you generally do in these kind of situations? You want to shut down the whole space for some time, or what do you do? How do you kind of rework on this scenario? If one of you can take this.
Maybe, you can ask a specific person. How about Dr. Yusuf? You want to comment on this?
Yes. First, this microbial contamination is a serious issue. The first thing, we need to inform the management about the issue and about the proposed plan. We need to make microbiological culture for the media to see what type of contaminants we have, and to make microbiological culture for the air, to make sure that it comes from the air. And if we have the two microbes, the result of the microbiological tests from the air and from culture media are the same, this means it's coming from the air. And For this, we need to redesign and renovate the air handling unit. Usually, we make the air handling unit, we equip it with pre-filters and then HEPA filter in the unit. After the HEPA filter, we have UV light that kill the microbes and VOC filter, and finally a terminal HEPA filter inside the lab. We need to check the performance of the terminal HEPA filters and change them every 6 months. In addition, we need to compensate the patients that were affected with this problem, and we need if the problem is not solved immediately, we need to stop taking cases because we will cause a lot of damage to the patients, and we cannot make a transfer or freeze embryos that are have microbial contamination.
Okay, thank you very much. Let us wrap it up. We are over the time, but I would like to finish with some important issues. The most important part actually is the disaster preparedness during the design. So what are, and this is an important consideration. A lot of people don't want to think of the disaster, and the disaster can be a hurricane, it can be a flood, it can be a, some kind of lightning or things like, some kind of a disturbance, or more importantly, things like pandemic. So is there something that we can do during the planning stage to consider these things, or this is just something that you just have to wait for the God to kind of take care? Is there something that one can think in terms of planning? So I want to ask Jason and Giles after to comment very briefly about these things and what kind of strategy they employ.
Yeah, I think, for us, giving adequate time during the construction phase is important, to not rush, whether it be, to prevent burn-in or just to deal with these little hiccups, whether it's a small hiccup or something big like a disaster, that we don't, start prematurely scheduling patients or making plans. And knock on wood, I've been pretty fortunate working with a team that hasn't kind of pushed the envelope. We know it's a delicate balance between the business side and the operational side. So I think, having a realistic plan and not pushing that timeline too much. In terms of laboratory design and actual construction, I think we've covered most of those things in terms of making sure you've got the right safety measures in place. Whether it's earthquake, if you're at an earthquake-prone location, making sure you have restraints for incubators and other pieces of equipment, generator backup, power backup, all the redundancies that we've discussed.
Okay, Giles, you want to add to that before we go to, and we'll skip this, we'll go to this, but Giles can comment about the disaster preparedness.
I mean, I mentioned one just earlier, which was about the submarine mode, which is a way, obviously, with forest fires that you can, in fact, close the lab. But what you really need, and it's a living document, is to have a disaster contingency plan or a business recovery plan. So when you're making a lab, obviously, you'll make a list of all the suppliers. You'll know exactly how to contact them quickly. As far as location-wise and building a lab, you'll have a series of what-ifs. So, for example, like your embryo storage, what if there's a flood? You have to have everything sorted out, and you can get the jurors out of that building. If there's a fire, perhaps, so you have to think about access. You have to think about lifts as well. Jason spoke about earthquakes, about making sure that the equipment is secure. But we're learning all the time. And just for example, we now need a pandemic, let's say, business recovery move. So we do have to see what happens in these circumstances. Now, we have learned from our mistakes, but each country will be different from their natural sort of situation, if you like. For us in Wales, we have a system which happens is if there's too much snow, if you like, and we cannot get to work. So you have to look at every process and every piece and have a what if and then a solution. And just finally, in this COVID pandemic era, we have these lists, but you will always forget something. And one of the things which we've now built on is to make sure that our lines of communication, whether it's telephone lines, whether it's staff, is up to date. So if we do have an emergency, we can gather up those people pretty quickly and delegate jobs to them. So again, it's a living document which you have to keep reviewing every year, if you like.
Okay, well, that was excellent advice, that this is a living document, and you really have to keep on updating it as the situation changes. So it's not a fixed thing that you have thought of all the things 20 years ago and then thought nothing will happen, and then you end up with some very unfavorable situations which will shut down your clinic. So I think by keeping your ear to the ground and kind of learning from various sources and updating your disaster preparedness plan is the key. So now we come to the most important last element, which is where we want to hear from each one of the panelists and also our host. So I will start like a round robin and have everyone talk. Here what we want to learn really, what are their personal experiences and difficulties that they have faced in their own professional career when they are involved in the construction and designing either of their own clinic or IVF unit, or the one that they are consulting and advising of their clients or associates that they are working with. So I will have one person comment maybe for 2 minutes and just give some personal experiences. Some of you probably will have more than others. So why don't we start maybe with, let's see, who would like, maybe we can have Dr. Alex speak first, and then we can go down the line.
Especially when you plan to start a clinic, that experience that sometimes people face in India, to get the right people for the design and for the ongoing construction. And also, one has to keep in mind that there should be a kind of a good correlation, kind of a good coordination between the investor who is going to start the clinic and the scientific staff. And another big issue is that it is very difficult to sometimes convince the people about the air quality. What's the importance of the air quality in the IVF clinic? So that need to be taken care of first. And the second thing is that many people who want to install, or the designers or the engineers, they don't have much idea about the activated carbon VOC filtration system. So that is one of the big difficulty to be taken care of that while designing that. Even I have faced, and also the good quality charcoal, because that is not readily available in many places. Even the because when you talk about the VOC, there are different items are there. There is activated charcoal, there is a potassium permanganate, and activated alumina. Because all three has got a different absorption capacity for different type of VOCs. So that has to be kept in mind.
Okay, thank you very much, Alex. The VOC is a game changer. So let's go and learn from our colleague from Faki, Dr. Youssef. Can you please talk about some of your personal experiences that you have faced related to what we are talking here today?
Yes, one of the problem I had almost before 1 year for one of our new labs for the AC system. We had one company that made the design, a second company that supplied the machine and ducts, a third company that did the installation, and a fourth company that installed the building management system, BMS. It's a system that controls all these units and controls the positive and negative pressures area, the humidity, temperature, and VOC. And when we started the system, we had a problem with the temperature. It was either very high or very low. Sometimes it reached like 12 degrees only, 12 degrees Celsius. And sometimes the VOC and particle counts were high. And this was due to lack of coordination among these for suppliers. So ultimately, I had to make a management meeting with the managers of all these companies, and I threatened them to hold all the payment. And at this point, they sat together, they coordinated together, and they solved the problem. And till now, the system works properly.
Great. Thank you very much, Dr. Yusuf. There is a lot of coordination that he is talking about between parties, different people who will be responsible for the construction. So that needs to be kind of navigated really well. So here we ask our friend from Welsh, Dr. Giles Palmer, and see if he has any anecdote or real information that he can share, but also some advice for people out there who are listening to us, and how should they be really dealing with this complex process of designing and construction of IVF units.
Sure. Well, I agree totally that it is a part of cooperation, and my message would be like education, and have everyone on the same page. So when you've got architects, you've got building suppliers, and people who do the installation, to know exactly that. Because, for example, personal experience, it's one of the main problems, although equipment is getting smaller, is to get some of the larger parts of a lab, like the laminar flow, perhaps, or incubators, into the actual lab itself. Okay, so if people understand the difficulties, then they can work out solutions. So keep everyone informed about the needs, and the embryologist is the best person to inform architects and planners of those labs. So that's my one piece of advice. And the other experience is always try and be there. As I mentioned, previously, you can turn your back, and you never know what people are trying to, stick down on the wall, or to sort of like contaminate your place. So it's to be vigilant, okay, and just to look after those very precious work environment, which is of course our home.
Thank you, Giles. I think we heard from Giles is education is the key, and which is really the truth. If people are well informed, I think they will be able to make good decisions. So with that, let us ask Dr. Jason Swain, and let's see what is his comment on this topic.
Yeah, really just kind of echoing what others have said. Our main hiccups tend to come with either the med gas or the air handling unit. We had an example where, despite trying to give constant oversight, local contractors tend to kind of go with what they know and don't, not always with what we've instructed them. And we've had things like, even though requesting ductwork be cleaned before it's been put in ductwork, sheetrock the ceiling, and then we climb up on a ladder and realize that the ductwork is filthy, still covered in oil, and having to then tear down the entire ceiling and redo it. Or installing in ductwork air filtration units, but blocking the access panels so that they're against a wall, where if we wouldn't have caught that, it'd be impossible to change filters or UV bulbs, and again having to then tear it down and reinstall. So going back to Dr. Palmer's and others' comments, constant oversight, policing the local contractors. Those are usually the nightmares that we end up running into.
Thank you, Jason. So constant oversight is the key. You cannot be too complacent and think that everything is going to just work out all by itself. It randomly can, but you can be in a lot of trouble. So let's ask our very energetic moderator, Dr. Parsuram, who is the head of a very important center in Kerala. Let us see what is his comment on this as well. Parsu.
So more than designing a lab, primarily I think the biggest challenge I was I'm facing here, even at this point of time, is getting the right gas, especially while using dry gas mixes and things like that. It's a big challenge in India, especially in the smaller cities, to get good quality gas, and that determine your actual outcome. Because a lot of times we always end up getting good quality embryos, but later on when we realize that we don't have pregnancies and early pregnancy losses, and this when we, in the end of the day, is when we later on realize that yes, but unfortunately we don't have an authority or kind of a quality management system here which can actually assure us about the quality of things. So a lot of things like that, unfortunately, in India we don't get, so that we can rely on other things. See, if we are sure about what quality we're getting as far as gas is concerned, we can actually look at other issues that we are facing here. So that was one, I think, one of the major extra things that we have very specifically in India.
Okay, thank you very much, Parsu. So Parsu says the problems in having good quality gases or certifying agency which can provide, maybe there is some business opportunity in this direction that that you can consider. If this is missing, why not do something about it? Believe me, because this is a very important area. I mean, you need to be able to have a very reliable quality of gases that are being used for culturing the embryo. And if that is not really verifiable and certifiable, then everything that the embryologist is working on can be compromised, as you rightly said. So perhaps something to consider. Let's have Dr. Pranav Ghosh, who's the director of Elixir Fertility Center, very beautiful name, to talk about his experience with this particular issue, his personal experience. Perhaps he can illuminate us.
So I would say that we should not be complacent regarding quality control. I mean, after we have bought a piece of equipment, I'm especially talking about Indian setups, single clinician ownerships. They have invested a lot in their equipment, but they are dependent on the people who are doing installations for the installation and the operational checkups. And I've found, at least in one of the facilities, right after starting, we had a spate of high miscarriage rates. And eventually we found that the stage temperature of the XC, even though it was certified to be fine, 37, 37.5 by the installation check done by the engineers, it was found to be 32 degrees. So as a takeaway from my time spent in the biochemistry lab and doing ELISA testing, I found it useful to have any reading to be done in triplicate. So have at least two set of quality control equipment so that you can do a triplicate of study value studies, and you can match it from the values that come across from the QC engineers. And it is worthwhile, it's worth your buck if you invest in a good digital thermometer, a CO2 analyzer, and a VOC meter, if not a particle counter, for Indian scenarios. So you have to become self-sufficient, as our Prime Minister says, become Atmanirbhar, become self-sufficient.
Thank you, Pranav. I think the key, according to Pranav, is quality control, quality control, quality control. 3 times. You have to take 3 times the reading and get the best out of it. So anything other than that, you are getting yourself into trouble. So with that, let us move to our last and most versified, very talented speaker and panelist, Dr. Sandro Esteves. And I have something that I want to show here. This is the book that Dr. Sandro and his beautiful wife Fabiola actually wrote, which is on quality management in ART clinics. This book has become one of the most important books in the world, and actually this book, yeah, I think Giles have it, was even translated in Chinese of all the language. So you can imagine it's not easy for Chinese to really ask for a book to be translated. They can do it all by themselves, but you know, we got maybe $2 out of that too. But I want to ask Sandro really about his feedback, his experience dealing, personal experience with constructing, designing, and maintaining an IVF unit. What kind of challenges, what kind of joy, what kind of difficulties one has, and how do you deal with that?
Thank you very much for the kind words, Ashok. First of all, I have been lucky to have my wife as quality manager in our program, so extremely lucky in that regard. So in terms of a personal experience, perhaps I could offer 3 pieces of advice. In the design phase, try to design your facility a little bit larger than you think you need for that moment, because renovation is quite complicated and you need to kind of stop doing the IVF cycles in many cases. So try to make things in the way that where I want to be in 10 years, for instance, and try to design it a little bit bigger. The second point would be try to be the technical expert in air quality control. Do not rely on what the companies are telling you. Don't take it for granted, because these companies, most of them, they are very well, let's say, versed in industrial, let's say, clean rooms, and not completely aware of our needs in the IVF community. So try to learn and bring the technical expert in when you are designing your lab. I think it's going to be very, very important. And the third point, I think the most difficult thing, and the Giles have said that, is about education. Because we can design the most beautiful IVF lab with a lot of quality control, the best equipment, etc. But if we do not educate and provide training to the personnel, they will actually generate contamination. And that's the most difficult thing. We need to keep an eye on training and education to have also all aspects integrated.
Okay, I think that was a wonderful recapitulation of everything that we learned from all our best experts, some of the best in the world. And I had a pleasure working with Dr. Persu and myself to moderate this session. I want to give this session back to our host, Dr. Alex, to conclude this session and give a vote of thanks to everyone.
Thank you, everyone, and especially my thanks goes to Dr. Agarwal and Persu for taking us through all the complex areas of IVF designing to construction to the commissioning, the validation, and finally to the running of the IVF unit in a nice way. I would like to thank everyone of the panelists who has contributed very much, giving a comprehensive and very brief answers to the valid points to each questions of this interesting discussion. And with that, we would like to conclude today's session. And unfortunately, we don't have a time for the Q&A. Those who have logged into the system, I'm sure that they have put a lot of questions. So we'll be taking up all the questions, and we will be making another session, and we will be revert back to all the audiences with their required answers. So I would like to thank everyone once again to take part in this educational event, and I'm sure that it is very much helpful for those who want to start the clinic and who want to renovate their programs, and especially the youngsters who are coming into this field for establishing the clinic. Thank you, everyone. Thank you very much.